Hi, this is the revision video for forces at foundation tier. The first thing you need to know in this topic is about the difference between scalars and vectors. Scalars only have a size, sometimes called magnitude. That would include distance, speed, mass, temperature. Vectors have a size and direction. So that would include displacement, velocity, forces, and acceleration. Sort of things you tend to draw arrows with. Vector arrows have two very important strands. They have to be the correct length, which shows the size. As you can see, the longer arrow has the biggest number. They also need to have an arrowhead to show the direction, because remember, vectors have a size and a direction. Resultant forces is when you replace all the other forces with one force. Now, if these forces are on the same side, like this 60 and 30, you add them together to get the 90, and the direction is which direction the arrows are going. When they are on opposite directions, you take away, and whichever side has the largest number in the first place will be the direction that it goes. So in this case, it's 30 take 10, gives you 20, and because the 30 was on the right-hand side, it will go right. Mass and weight are always confused. Mass is a measure of basically how much matter you have. It's the same no matter where you are in the universe, and it's always measured in kilograms. Weight measures how heavy an object is. It's due to how strong the gravity is. It's a force, so you draw them with an arrow, and it's measured in newtons. So as you can see, this person is standing on the Earth, and their weight is 560 newtons. When they're on the moon, it's 90 newtons, because there's less gravity on the moon. But the mass of the person was always 56 kilograms. You need to know how to measure mass and weight. Weight, because it's measured in newtons, is measured using a Newton meter. Mass is measured using a balance, not a set of scales. The weight of the force all seems to come from the centre of mass. So the centre of mass would be there. The WMG calculation. You do need to learn that weight is mass times gravity. So weight in newtons, W, M, mass in kilograms, G, gravity in newtons per kilogram. The mnemonic for this is worms munch garbage. Worms munch garbage. The next calculation you need to learn in this topic has a slightly more confusing element. This time, we've got work done, which is also W. Now, work done can also stand for energy transferred, so it's measured in joules. Force, just like weight, is measured in newtons. S is distance in meters. Wet foxes stink is the mnemonic for this equation. The final equation in this topic is FKE. Again, F is force in newtons, K is spring constant in newtons per meter, and E is extension measured in meters. The mnemonic for this one is French kangaroos exist. To measure the extension, you need to measure the difference between the original length and the stretch length. It's a little takeaway sum. This leads us nicely onto the required practical. You are expected to have a rough idea of the method to get your results. So attach two clamps on a clamp stand, attach a spring on the top clamp and a ruler on the bottom clamp. We tended to hold our rulers because we didn't have enough bosses and clamps, but in an exam you can say use a clamp. You move the ruler to make sure the zero marks at the level of the spring, measure the length of the spring, record it in your table, add 100 gram mass to the spring, measure the new length, and this is the important bit, calculate the extension, doing stretch, take original, and you repeat adding 100 grams each time until you've done 500 grams. 5 tends to be the magic number of measurements you need in a practical. That practical is a Hooke's law experiment. Now, Hooke's law is all about stretching a spring. Now, when you stretch a spring, it will be directly proportional. Okay, so it'll be straight line through 0, 0, until it reaches what's called the limit of proportionality. That's the limit at which the spring will not continue to stretch and follow Hooke's law. The way you find your limit of proportionality is you put your ruler on and you look where does the line start to curve. Okay, what proportionality means is every time you add 1 Newton, it stretches that bit further. So, for example, at 1 Newton, if it stretched 2 meters, when you've added 2 newtons, it would stretch 4 meters. So it increases by the same amount each time. That's all of forces.